Hi everyone, welcome to another episode. Let's get on with the question. So today's question is: you're given a 2D grid map of ones and zeros. Ones meaning it's land and zero meaning it's water, and we need to count the number of islands. So, a definition of island is that it's surrounded by water and it's formed only when there is adjacent lands horizontally and vertically. You may assume all four edges of this grid are surrounded by water. Okay, so let's look at the um, input to understand how they are generating islands. So let's say I have one, two, three, four, five. Okay, and then zero, 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 zero. Okay, so if I am standing here, right, then I can, then this is the connected land. So this is also an island, this is also part of that island, this is also part of that island, because it's all horizontally connected. And then this is vertically connected, this is also vertically connected, this is vertical. So basically this is the count of one island. So here we have one island and we don't have any other island right now. Let's look at the other example. Okay, so I guess one island is this, one island is this, because it's not connected horizontally or vertically to this part. Otherwise, if one was here or here, then this would be a part of an island, and then another island is this. So in this case, our output is 3. So how can we solve this? The approach that comes to my mind is, if I am standing here, right, I can move in 4 directions, like let's say this this up and this. Obviously in this corner case, up and left would be out of bounds, so I don't navigate there, but I can traverse in 4 directions. So basically if I'm at I comma j, I can go in I plus 1j. Sorry, this should be I comma j plus 1. My bad. This should be I plus 1j. This should be I comma j minus 1. I minus 1 comma j. Right. So we can go into 4 directions. Now I am thinking of using extra memory, like a array, a 2D array, which I would call it visited. And then basically what I'll be tracking this visited for is, whenever I traverse any cell, if I'll mark it as this value at that cell as 1, so then I know that I already have traversed that cell. If I come across a 0 cell, then I just break out, like I can't travel there, because 0 stands for water and it's not land, right? So I'll be making use of this extra 2D array. So if I start from, let's say, this 0 comma 0, so then I go to this direction and I mark this one, then I come here. Now from here I go into 2 directions and I mark this one, then I mark this direction and this direction. From here I go to this direction and I can't go here, so I will cut this call and I mark this one and I go here. So similarly, why I'm using this visited is, let's say I start my navigation in this case, let's say, or maybe in this case, let's say I start my navigation from here, but this is already visited, because if I've started my navigation from 0 comma 0, then this cell is already covered when I am traversing, because this makes me go here, then this will make me go here because of I plus 1 comma j, and then this will uh, uh, have the traversal go here. So this eventually will be visited, so I don't need to visit it again because this is a part of this island already. So this will help me to keep track of that. Let's jump into the code to understand how can this be approached. So I'll take a visited array, or maybe I can give it a vector, visited. And then I will do a DFS on it. DFS. So if I is our x value, which is a row value, n is the number of rows, n is the number of rows, m is the number of columns, number rows in the grid, cell value, cell coordinates. So if I is greater than equal to m, or I is less than 0, or j is less than equal to n, or j is less than 0, we just return it because we don't need to traverse it. If we already have visited I comma j, then return it. If rid of I comma j 0, then return. If none of these conditions are true, that means it's 1 and we haven't visited it yet. So I will mark this cell as 1 and I'll call DFS on 4 directions, right? One would be red, okay. And then here what we are gonna do is I'm gonna resize my vector. I'm just initializing the visited array with 0 values. Now I will just do iterate. I will keep a count of islands. And I'll iterate over the grid. So because my visited area is a global value, I am tracking the visited cells, so I don't need to visit them again. If not, so basically if not visited, then only I'll run a DFS on grid comma n comma m comma I comma j, and after that I increment the island, because if it's not visited, and obviously I need to check grid of I comma j is equal to 1. So if it's 1 and I haven't visited it yet, that means that would be my start, or that would be my piece or in the grid that of the island that has been unexplored. So I would like to explore it, and once I start exploring my whole island, I'm gonna explore all the connected components. So I will increment the count island once this DFS loop is completed, right? And then I just return. Let's see. Okay, seems to be working. Okay, so in case the grid is empty, hmm, this is the corner case here. Let's run this now. Awesome. I hope this video was clear. It was pretty straightforward, just to basically traverse over the connected piece of the grid. And once we have traversed a particular connected piece, I'm incrementing the count. So that is the count of number of islands. Overall time complexity of this program will be O of n square, because the grid is 2D, so we need to traverse through all the elements of this grid. Hope you guys enjoyed this video. If so, please subscribe to my channel and give me a thumbs up. Thanks everyone.